My name is Michael Dickman. I lead product management for Aruba switching, and I'll be joined by Les Stewart, who leads management, automation, orchestration for that area, and Scott Coster will come on in a moment. He's a software product manager. Okay, so AOS-CX is something we did I think, Tech Field Day on back in 2017, and we wanted to give a little bit of an update on that, and thanks for, I think, a couple people who were there. I know you were there as well. And so it has really three elements. So we talk a lot about the switching, but there's actually three things together. It's not just the switches. It's the software, the AOS-CX, and I want to talk about that. It's the hardware themselves, and then also the analytics and the automation that we drive on top of that. And so I'll just spend a moment on each of these. I'll touch mostly on the software. So AOS-CX is an operating system that we had built from the ground up. I'll talk more about that, but it is a very modern, fully microservices, database-driven, modular operating system. I'll talk a little bit about that as a reminder of the advantages of that architecture, and then Scott will go through how we apply those capabilities in the data center context. From a hardware perspective, we have a carrier-class chassis, the 8400. That's what we had shared with Tech Field Day back then. And then now we also have a number of other hardware form factors as well, but this is really just packaging around that operating system. And so, if you need 48 copper or 32 by 40 or, whatever you might need, but in terms of that operating model, that's really what we're targeting. And so how do we drive a much more modern operator experience with the right form factors underneath? And then finally, Network Analytics Engine and NetEdit. So Network Analytics Engine is something we've had from the very beginning. It's actually analytics embedded inside the infrastructure. So this isn't like an application off to the side. It's inside the infrastructure itself. And what that lets you do is have complete visibility. So there's no question of what do I stream, where do I stream it to, how do I handle that bandwidth, et cetera. Those questions don't exist. Rather, you distribute the analytics out to the switch infrastructure. And so every node is not just a sensor, but an analyzer, if you will. And so that way you can embed particular analytics into that infrastructure. And so we call those NAE agents, which in essence are scripts that have full access to what's happening inside the switch, but can also talk outside. They can talk to ServiceNow, they can talk to a downstream switch, they can receive API calls, trigger API calls. So if you're familiar with if this then that, essentially anything that is an API call inside or out is good to go. And so that's very powerful, and we've had that from the beginning. Now, one of the challenges of distributing analytics is how do I actually visualize that? Right? If every single network node is its own analyzer, how do I control that? And so we'll be talking a little bit about that today and more in the future about how those things come together. And a lot of that answer will be NetEdit, which is how we are driving automation of a lot of the traditional operator workflows. So I'm setting up a switch and I need to configure that. I want to make a change to a switch. But more likely than just those two is I'm deploying a network. I want to make a change to a network. How do I know that I have validation, verification, assurance of the changes at the network level, not just per individual switch? And so really starting to look at all of those things together, and we'll have a demonstration today of those. So the last introductory comment I wanted to make was on the OS itself. And this is a stylized representation of what is AOS-CX. I'll walk through that briefly. But first I want to key in on something that we're starting to hear more about in the industry, which is this phrase cloud native. Right? And you'll hear that obviously on the application side. It's a cloud native app. It was built to run in the cloud. But you also are now hearing about cloud native infrastructure. So that's infrastructure built with cloud principles. And Gartner has actually defined that. And so they define that as four things: modular, programmable, elastic, and resilient. And that definition was not intended to be for networking, actually. Right? So you should have infrastructure that's modular in the sense of, how do I add compute nodes, for example, or elastic with bursting. But if you think about really why those things are there, we believe they do apply to networking. And we're really embracing the idea of cloud-native infrastructure, which is what AOS-CX is. It is actually completely modular, as I'll talk about. It is completely programmable. It is resilient by design at the level of individual processes, up to a switch and out to the system. And we'll talk about that in terms of layers of resiliency. And then the elasticity and scale is really, there is a lot of powerful performance there. And you can get that same operating model in different form factors. So now I'll touch on the OS. I mentioned this microservices database driven. That's kind of the bottom two layers here. there is no inter-process communication, so that's this database-driven point. Everything is represented in a state database, and so if one process talks to another process, it publishes, subscribes into the database, and then if some other process needs an element of state, it can subscribe to that. So publish, subscribe. And so you may ask, so what? Why does that matter? It dramatically simplifies feature development in terms of velocity. It simplifies and improves quality. And so that means that we can have a lot better delivery of incremental features, right? So what has plagued the industry in the past is I build some great features, it's awesome, and now I add another feature, and another feature, and another feature. And by the time I get to the 1,000th feature, I'm spending 5% of my effort developing that feature and 95% of my effort making sure I didn't break something when I added that incremental feature. And the state database architecture significantly simplifies that process. And so one example that, that we have here is if a process were to fail or crash in a live switch, it does not actually cause a system failure. What happens is just that process crashed. And it can actually restart itself, get last known state, and continue on. And we've had that actually happen in production, unfortunately, but also fortunately. So you have resiliency in even the process level there. So you have this feature benefit level, resiliency benefit, and quality benefit. Now, once we have the state database, we can have everything be exposed, because every piece of state is represented. So how many BGP neighbors do I have, or the configuration, so either persistent or ephemeral state is represented. And so again, you might say, so what? We can now expose that via API. And so we have 100% REST API coverage of everything in the state database. And that changes that question of what can I program to how do I program. Because literally, when we say full programmability, it is fully programmable. Anything is possible. And so the new challenge becomes, how do I make it easy to program? How do I identify the right problems that I want to drive automation on top of? Because nothing is not able to be programmed. And so that is why we've added the next two pieces. The time series database lets you, within each individual device, record what is happening. And I'll come back to that. And then the network analytics engine above that can now look at everything below. So it can look at any piece of state, and it can look at what's been happening. So again, that if this then that framework I mentioned, if can now include not just a current state or a current question, but if there's been some pattern of behavior. If something has been going on for 15 minutes, or if the number of BGP neighbors changed too rapidly. And so you can start to think how issues maybe like link flapping or other things that could have been transient or hard to track can now be monitored and recorded very easily. And so that's now really granular. And then what you'll see in a moment is if you look up from an individual switch at a network level, you can now take advantage of that in a really powerful way if we give the right application level interface with such a powerful low-level device. So that's just where I wanted to open up in terms of AOS CX. I'll give a very quick business update, and then I'll turn it over to Scott. We have been in the market for a couple of years. We've passed the 1,000 customer mark, which is pretty significant. As a reminder, again, this is core aggregation data center, and those aren't things people change overnight. We're now swapping out approximately 80 network cores a month. And again, that's a pretty significant decision, right? If I want to change my network core. About half of those are replacing, a well-known vendor that begins with C. About half of those are replacing, ourselves or a number of other vendors as well. And what's really resonated is the possibilities with this infrastructure, but also, frankly, the quality and performance, right off the bat in terms of what we have to offer. So we're very pleased with that. The other comment I'd make just on the business is it's remarkably diverse in terms of verticals. We initially thought this might be a little more oriented to higher ed, for both how higher ed likes to purchase and our significant market share in higher ed. But we've found oil and gas, financial, media, now we're even into healthcare. And so some of these organizations that are traditionally very conservative and concerned about quality are seeing this as a solution to their problems. For example, things like live upgrades, that you can upgrade the network without a maintenance window. That's something that hospitals are very interested in. And so that's one of the reasons we think this is being embraced at the pace that it is.
So on that point in the verticals, we were talking about the chat. I was here when you guys rolled out the 8400 chassis and you did the NFDX event.
Yep.
And at that point, it was just a large chassis. And now you're saying you've got this all the way down into I think the edge, is that right? That you've got that?
No, so I
how
was
far
saying,
down does it go?
Yeah, I was saying we have this in fixed form factors.
Okay.
So it's basically top of rack or a fixed aggregation form factor. So,
Okay, so that's like a 1U switch.
yeah, it'd be 1U.
Like a 10 gig switch. Does it go down to a 1 gig yet, like a PoE?
So no 1 gig PoE yet, but it's things like 48 by 10G base T, 48 by SFP plus, 48 by 25, 32 by 40, et cetera. So those types of.
Any plans for that to move even further down from a speed standpoint into smaller switches?
So it's obviously not a kind of roadmap communication forum here, but that's like a very logical thing that we would look to do, you know, given the operator experience benefits we're seeing that are proven.
Gotcha.
I have a question. Do you have like a virtual machine version of AOS CX? If somebody had no experience with it, wanted to play with it in a virtualized environment?
That's a great question. We do. So we have an OVA of AOS CX, and it is, I'll have to follow up on the details of how to download and get it available, but we do have an OVA of that. It's not identical as you can imagine, right? Because there are things that are platform independent and things that are platform dependent. But to get to know it, and actually even to run some protocols, sometimes with no actual behavior and sometimes yes with behavior, we do that in the OVA. And just the other point I'd make is that's actually one of the ways that this has helped us with test automation, is the platform independent features, we actually do first round of tests in an OVA. So that lets us do massive test volume in a much easier way.
You mentioned having a REST API gives you programmable access to all the things.
Right.
In terms of documentation for your APIs and such, could you kind of talk a little bit about how comprehensive they are, or how somebody might find out more information? And do you provide, I like to call them cookbooks, that really tell you how to use APIs to accomplish some kind of workflow or task? Because just seeing a list of API endpoints is helpful, but it doesn't really give you the insight in how to glue them together to do something specific.
So I'll give a quick answer, and then cognizant of time, I'll move on to Scott, and then Les will come back to that, I think is something we can do. But basically, because of the volume and the fact that they're auto-generated, we actually do have, you could say, auto-generated documentation, of how that is structured and what it points to. But then we are also commenting that as well, because you need a human interaction to comment. And so what you have there then is basically a mapping to, they're essentially like URLs or URIs in terms of how to find that API. And so then you can identify what that is and where it points in the system. And so that's then a complete and comprehensive document. But to complement that, then we need to comment on that. And the other thing we found that's useful, which isn't, I wouldn't call this API documentation, but useful, is we have a lot of Python scripts that we have built that are very well commented. And that'll show a whole workflow with multiple APIs. And we're finding that that is a very useful way as well. So not just how do I find the right API for me, which is there, but also how would I use a number of these APIs in concert to achieve a workflow goal. In fact, we're even using that internally to share. When people request documentation, we're giving documentation, and here is how you would achieve a somewhat complex goal using multiple APIs as a full example.